Okay, so this is kind of a cool question. This is Horner, and this is rotational energy and momentum, question 4. So somewhere in space, far from gravitational effects of any large objects, an astronaut takes this magnetic puck and pushes it towards this bar. And when this one is traveling, notice it's not doing anything other than hitting the center of the bar. And when it does that, the two stick together and they move together to the right. When this one is thrown, though, this one sticks and then the whole thing rotates. So you'll notice that this one will rotate about the center of mass, which probably is going to be up a little bit higher. So it'll probably, when it rotates, it'll do something like this, and you'll have that center mass there. This one, when it hits later in the thing, you would have this situation. So it does not rotate. Because this one doesn't rotate, it takes the full brunt of the push of this disk, and it gives off some heat, and it would also give off some sound. Okay. This one, because it rotates, will absorb more of that energy and convert that into the kinetic energy that we know as rotational kinetic energy. So in which cases is the linear momentum conserved as a result of the collision? It is in both cases. And it's because they are both some sort of inelastic collision. So it's an inelastic collision. In which case is the angular momentum about the center of mass conserved as a result of the collision? And that's also in both cases. Because that linear momentum and angular momentum, you can say, hey, they are conserved. So in the absence of any external force, both the linear and angular momentum conserve. So that's the easy part. This one is kind of cool. It says, in which case does the greater amount of kinetic energy transform into other forms of energy? So the only other forms you can think of here are going to be heat and sound. If it really hits it hard, it might give off a little bit of light from a spark. But this one is going to be case 1. More of it is converted into other forms because in case 1, the system doesn't rotate. So more of that energy from this collision is going to come off probably in sound more than anything else, but also in terms of light. But you say, now wait a minute. There's no sound in space. Oh, yet there is. Just a little tiny bit from some very random molecules that may be out there. Nonetheless, if it doesn't create sound, it's going to create heat. And so this one's going to create more of that because there's a more solid collision here, and we don't have any rotation like we do in the second part. So you basically just need to say here, in case 1, the system doesn't rotate, so more energy is transferred into other forms of energy. In case 2, the kinetic energy linear is partially converted into that kinetic energy rotational. Probably not total, so you're still going to get a little bit of energy loss, but you're going to get a ton of energy loss from case 1. Yay, that is the end of all the packets. You can celebrate, hallelujah, and your final is coming up.